it's not too difficult. Oh, let's do 3 5/8. 3 5/8. Now, the word and itself means plus. So we have 3 5/8. Now, I used to work at a fabric store, so I had to have 5/8 memorized, but I'm going to assume that a lot of you do not. So let's go over here and do what we learned last night. 5/8. Okay, so we're going to put the 5 in here. 8 will not go into 5. I'm going a little bit faster because this is the second night we've done this. So I'm going to put an X there. I need a terminal 0. 8 will go into 50. How many times? This one's a hard one to remember. 6 times 8 is 48. All right, so we're going to go with 6. We have 48. We subtract. We got 2. 8 will not go into 2, so I'm going to need a terminal 0. I'm going to bring it down. 8 used to go into, it always goes into 20 2 times. Thinking about fabric stores again. 2 times 8 is 16. And I subtract. Still not done yet. I need another terminal 0. But those of you who know your multiplication tables well have probably already figured out this is going to end well. 8 goes into 40 5 times. 5 times 8 is 40. All right, so the decimal equivalent of 5/8 is 625 thousandths. Now, that means the decimal equivalent of this, our original question, is 3 625 thousandths. So that's the question we were answering. Now, just as a, be sure we all know what we're doing here. Well, maybe we're going to get PDF back. Maybe not. Just to make sure we all know what we're doing. What if I want to go from 625 thousandths to 5/8? That's what I'd like to show you. 625 thousandths. Now I keep saying 625 thousandths, so that means it's 625 thousandths, right? And then you're going to, just like the other night, and we're not going to go through this today, we'll do some in class. What is the biggest number that I can make a 1 out of? This should be a division sign. To divide, to simplify that. We know it's going to be 5/8 because we just did all the work. But what is that number? Just think about that while I go back and try to catch what we were doing before and not make this video too long. Alright, this is the next page. Now this is the first kind of tricky fraction where we're going to have a repeating, non-terminating decimal. This is also a really good one to have memorized. So when we're talking about 1/3, we're going to do the same method. 3 goes into 10 3 times. 3 times 3 is 9. We're not done, so we got to keep going. 3 goes into 10 3 times. 3 times 3 is 9. And it doesn't take too many times for all of you to figure out that this just goes on and on and on forever. And you learned in another grade that when you have that, you just need to write that. That's a bar notation right there. That bar notates that it's a repeating decimal. So that's why they're showing you 1/3, to be sure you understand that. And there are some other common repeating decimals. Now, this says write fractions as repeating decimals. So write each fraction or mixed number as a repeating decimal. 7/9 isn't one we work with very often, but if you'll look here, you'll see when you do the division, you're going to get repeated 7. 7, 7, 7, 7, 7. And I'm not going through the division because we did that at the beginning of the year, and you just did that in success time. So hopefully the division is solid now. When you're working with a mixed number, you treat the whole number and the fraction separately. And this is one of those handful you want to have memorized. All right, so at this point, let's just try a couple together. Just one together. One like this, and we just did 3 5/8. I must have been psychic. So maybe we'll do 1 5/6 and 2/5. Let's do 2/5 and 1 5/6, and then we'll call it a night on the homework. All right, so 2/5 and 1 5/6. All right, so for 2/5, we're going to go 2 over 5, which is a division problem. All fractions are division problems. We're going to get our terminal 0 ready, because if we're thinking mathematically and fluidly, we already know 5 will not go into 2. So we're going to put our x there. We do know that 5 goes into 24 times, and that's pretty nice and neat, and we just finished that up. So 2/5 is equal to 4/10. Now, if we want to turn 4/10 into a fraction, and maybe check and be sure we're right, it's never a problem to check your work. This is 4/10, so I'm going to put 4/10. And then what can I divide 4/10 by that equals 1, so I don't change the value? I think probably 2, and I hope most of you came up with that when I gave you that little bit of time. 4 divided by 2 is 2, 10 divided by 2 is 5. And again, do not confuse this with the algorithm or the way we do dividing fractions, because this is 1. And 1 is a weird number, and it has all its own kind of stuff that goes with it. All right, now let's look at 1 5/6. We're going to treat 1 5/6 separately, because and means plus. 1's easy, so we're just going to put the 1 over here. Now let's look at the 5/6. 5 divided by 6. This is one I never had memorized for the fabric store job, so we'll figure it out together. All right, so we're going to put this on the top, because we know 6 will not go into 5. 6 does go into 50. Remember just a little bit ago we were doing this one? So I think maybe 8's a good place to start. 8 times 6 is 48. I'm going to subtract and get 2. I'll do it officially so you can. Hopefully, at some point, you won't need. You can kind of do it in your head mentally, but you're probably at an age you still need to write it out. So I'll try to set a good example. 6 goes into 20 3 times. 3 times 6 is 18. And then look what's happening. Bring this down. We're going to get a 3. 18. Gotta do another one. Is everybody pretty much convinced this is going to be a repeating decimal? All right. So we are going to write this like that, because the 8 does not repeat. If it was 8 3 8 3 8 3 8 3, we put a bar over both of these, but it's just 8 3 3 3 3 3 3 3 3. Okay. Now, converting this back into that is a little problematic because of the repeating thing going on. The 1 is easy, but it would be 83 hundredths. And it's kind of hard to find something that works this way. So maybe we will discover a way to do this in class when you're all working together. How do we take a repeating decimal and prove that it really is that fraction without a calculator? With a calculator, it's easy. All right, so you will have a WSQ, a WSQ, that you will look at. I'm sorry this video is a little bit long with all the technical glitches, but I will get better at this, and so will you, and we will do some work in class. Thank you very much.